Hello everyone, this is Mehmet. I'm a postdoctoral fellow in Robotics Institute of Carnegie Mellon University. Today I'm going to present our paper, which is about vision-based counting of pedestrians and cyclists using stationary camera data. In this paper we proposed a vision-based cascaded pedestrian and bicyclist counting system, and we extended the state-of-art object detector pedestrian detector method for static camera input, and we improved the false alarm rate of this detector at the same true detection rate by 3x, and we also introduced a new pedestrian and bicyclist dataset called as the PetBike dataset. We built a cheap and portable data recording system. It consists of Panasonic toughpad, extensible pole, and miniature bullet camera. By using this system, we recorded about 50 hours of video, which is about 1 million frames, at different intersections of Pittsburgh, which has some bike and pedestrian lanes. We labeled 10 hours of this data, and the labeled data includes 270k pedestrians and about 50k cyclists. And the labeled data also consists of about 541 unique pedestrians and 150 cyclists. Here's the pipeline of our proposed detect track counting method. In the first stage of the pipeline, we apply a cascaded classifier. In the first level of the cascaded classifier, we distinguish between the background and the humans, and later in the second stage, in the second level of the classifier, we classify between the pedestrian and the bicyclist. And in the second stage of the pipeline, we do data association between the trajectories and the detector outputs. And finally, if this trajectories past a virtual line, we count them. So by adding some new cues to the second stage of state-of-art pedestrian detector, we extend that method. These cues are foreground detections, temporal moving direction, detector confidence score, spatial proximity, and since we are using some stationary camera data, we can also use some geometric scale priors. To analyze the performance of the extended detector, we directly use pre-trained detector with state-of-art detector with Caltech dataset, and we run this detector on town center dataset, which includes 4,500 frames and 230 unique pedestrians. And we will be able to reduce the false alarm rate in this town center data by 3x at the same true detection rate. And also we will be able to obtain better well-fitted detector outputs, which is very useful for the tracking part. And in the tracking, we use for about close to 300k samples. We train our classifier using this data set, and we use a baseline tracker which matches the trajectories between the detections, between the spatial proximity and moving directions. And here is the confusion matrix. We achieve 95% accuracy in the counting results. Let me show you some video results from our datasets. You can see the counting numbers on the left top part of the video. Okay, thank you so much for listening to me. Please see me in the poster session if you have any questions and need more details.